Hi, I'm Mr. V. This is Illustrative Mathematics, Unit 4, Right Triangle Trigonometry. And this is Lesson 9, using trigonometric ratio to find the angles. And by the end of the lesson, you should be able to say, I can use the arcsine, arccosine, and arctangent, what are those, to find measures in right triangles. That's what we're learning about today. For the warm-up, you're given this right triangle as a 3, 4, 5, and we want to find the angle measures. If you have your right triangle table handy, you might be able to do it that way. The way I solve any of these right triangle problems is I'll write down my trigonometric ratios so that I don't goof them up. Let's see. I have the sine is the opposite of the hypotenuse. That's so. The cosine is the adjacent over the hypotenuse, ka, and the tangent is the opposite over the adjacent, toa. And the acronym SOHCAHTOA is to help you remember those trigonometric ratios. My second step would be to label the sides. And from this triangle, from this angle as my reference angle, this would be the opposite, the adjacent, and the hypotenuse. And I can choose any ratio I want. If I chose, let's see, if I chose 4 over 5, the opposite over the hypotenuse, that would be this ratio. And that would be the, see, this is the cosine adjacent of the hypotenuse. This is the sine, and this would be the tangent. So the sine of angle A would be equal to the ratio of 4 over 5. And as a decimal, that's 0.8. Can I find that in the table here? It's not in the table, but it's somewhere between these two numbers. And that means it's somewhere between these two. So if I said it's about 55, so this means that for this to be true, angle A would have to be about 55, I don't know, maybe 55. And if this is 55, this would be whatever that is, subtracted from 90. So that'd be, what, 35? And just like there's a way that you can ask the calculator to tell you any angle instead of just the ones that are in the table, you can also calculate the angle given the ratio. So if you know the ratio, you can calculate the angle. And there are several possibilities. In this example, we're going to start with 3 over 4. And I'm going to show you how we get to 37 degrees. So if we take the tangent of that angle is 3 over 4, this means that, well, first of all, what is the inverse of multiplying? Dividing. What is the inverse of adding? Subtracting. What is the inverse of squaring? Square rooting. What is the inverse of the tangent? We write it like this. I'll do this in a different color. We write the tangent. The inverse tangent is written like this. And here we have the tangent of the degrees is equal to a ratio. To switch those, to make it to where I can solve for the angle instead of solving for the ratio, I have the tangent of the ratio, the inverse tangent of the ratio, and we say arctangent, that's the way we would say this, arctangent, is equal to the degrees, theta degrees. I can plug this into the calculator. Let's see, the inverse tangent of 3 over 4. How do I do that? Please watch my screen. I'm going to show you inverse tangent. These inverse functions don't appear on the main screen. If you go to the function screen, there's the inverse tangent. Let's see here, make this nice and big. The inverse tangent, and we said the number was 3 over 4. 3 divided by 4 is equal to 37 degrees. It's about 37 degrees. And that's what I said I was going to show you, is that it's 37 degrees. When you plug this in a calculator, this gets me the degrees. So the rest of the class period, we spend trying to do that. For each of these next 3 problems, you're to find the missing side, the missing angles. Please try to do this on your own before watching the video. I'm going to show you a couple of ways of doing this, and these are not the only ways. There are several ways of doing it. Here I have a right triangle. I'm looking for this missing side, and I'm looking for these two angles. We'll call this one Y and this one Z, maybe. No, call this one angle C and angle B. Angle C and angle B. One way to solve for x is to use the Pythagorean theorem. A squared plus b squared is equal to c squared. So the hypotenuse has to be over here. I could write SOHCAHTOA and I could write and label my sides. This is the hypotenuse. From reference angle at C, this would be the opposite. This would be the adjacent. So the hypotenuse in the a squared plus b squared is c squared is always the c. This would be 10, or it's this one on this side of the equation. So 10 squared is equal to 9 squared plus x squared. This is 81 plus x squared is equal to 100. I subtract 81 from both sides. X squared is equal to 19. X is equal to the square root of 19. That's the exact of 19. That's the exact answer. Somewhere a little bit more than 4, between 4 and 5. Now to find the angles, I'm going to use these two sides, the opposite and the hypotenuse, because I know that these are nice numbers. They were given to me. I could use this number, but I'm going to use these two numbers. And the opposite and the hypotenuse is which trigonometric ratio? Opposite and hypotenuse would be the sine. We know that the sine from angle C, our reference angle, of angle C is equal to the opposite, 9, over the hypotenuse, over 10. To do the inverse operation, I will do the arc sine, written this way. This is not an exponent. This is not to the -1 power. This is the inverse sine, or the arc sine, of the ratio is equal to the degrees. And when we plug this into the calculator, we have 9 over 10. So I'll do the function inverse sine of 9 over 10, and I get 64.1 degrees. C is equal to 64.1. And then to find this other angle, I will subtract this from 90. When I subtract this from 90, I get 25.9. The next problem, I'm going to show you a different way to solve this. I could use the Pythagorean theorem, but instead I'm going to go from this reference angle. This would be the opposite, the hypotenuse, and the adjacent. I'll write down SOHCAHTOA. And the opposite over the hypotenuse is again the sine. The sine of angle E is equal to 4 over 7. So the inverse sine of the ratio is equal to the angle. So E is equal to, we do inverse sine of 4 over 7. Inverse sine of 4 divided by 7, I get 34.8 degrees. 34.8 degrees. That's this one. To find this other angle, I'll subtract that from 90, in which case I get 55.2. Now to find this missing side, let's call it x. I could use a squared plus b squared is c squared. Or, since I know the angle, the adjacent and the hypotenuse would be the cosine. So I could put the cosine of 34.8 is equal to x over 7. Multiply both sides by 7, and I get x is equal to 7 times the cosine of 34.8. What do we say? 7 times, I don't want radians, I want degrees. 7 times the cosine of 34.8. And I get 5.7. So my x value is equal to 5.7. Could use the Pythagorean theorem from this. This is the opposite, the adjacent, the hypotenuse. Opposite over the adjacent is the tangent. The tangent of angle G is equal to 6 over 5. How do I know that? Well, I remember SOHCAHTOA, SOHCAHTOA, TOA, opposite over the adjacent. It's the tangent. So the inverse tangent, or the arctangent of the ratio, is equal to the degrees. If I do this in my calculator, 6 over 5, the inverse tangent of 6 over 5 is 50.2. So G is equal to 50.2 degrees. To find the other angle, I'll subtract this from 90. If you subtract 50 from 90, you get 40. I'm going to subtract 60.2, so I'll get 39.8 degrees for this one. To find this missing side, hypotenuse, I could use either the sine or the cosine. The sine, let's see. The sine of 50.2 degrees is equal to the opposite divided by the hypotenuse. Cross multiply, you get x times the sine of 50.2 is equal to 6. Divide both sides by the sine of 50.2 to get 6 divided by the sine of 50.2 to find this missing hypotenuse. I could have used the Pythagorean theorem. Maybe you find that easier. 6 divided by the sine 50.2. And I come up with 7.8. So x is approximately 7.8. 52 degrees, 50.2 degrees, 39.8 degrees. The rest of this lesson, there is an activity here which involves a ladder, and you can try it out if you want. It's kind of interesting. When you hold your arms out to the ladder, the ratio makes it a safety issue from your feet to the ratio. You can try that out if you want. The next thing you were supposed to do is to write as many equations as you can for this. You could have thought of the Pythagorean theorem. Maybe if you take alpha, the angle at D, you could take the sine, the cosine, and the tangent. Or if you take the angle at theta, you could say the sine, the cosine, and tangent. If you have the angle, you could write the arc sine, arc cosine, arc tangent from alpha or from theta. So a lot of different angles. And so what they do is they give us some values here. This is 18 and this is 22 to solve for these other sides. I would use the Pythagorean theorem to solve for E. And to solve for one of these angles, maybe you solve for alpha. This guy's alpha. This one at angle D. From this angle, this is the hypotenuse, and this would be the opposite. So the opposite of the hypotenuse, SOHCAHTOA. So that would be the sine of angle alpha, which is the angle at D, is equal to the opposite over the hypotenuse. So the inverse sine, or the arc sine of the ratio, is equal to the degrees. And we plug this into our calculator, 18 over 22. Inverse sine of 18 over 22. And I get 54.9 degrees. So this is 54.9 degrees. this would have to be the complement of that. Subtract it from 90. When I subtract this from 90, I get 35.1. And the closing is you have this triangle. It's 8, 5, 8, 15, 17. We know it's a right triangle. It's a Pythagorean triple. The question is, what is the angle? And you can take the tangent or the cosine or the sine and then do the inverse of that, or the arcsine, arc cosine, arctangent. I'm not going to do it here. I'll let you do it. Good luck and success.